what is the historical development behind the fact that now we use that? You told me that you study theoretical computer science, right? You told me that, right? Okay. So our German friends should know this. No? Okay. Have you heard about Lambda calculus? Any of you? Never in your life. Okay, so it's one of the theoretical foundation, theoretical way of understanding, not computers, but programming. Okay, and essentially, and these are the foundation for many. It has been used as the semantic foundation for many programming languages in the past, and especially for what we call functional programming. And this relation between this and this is why we call this is Lambda. Because Lambda, in the mind of computer scientists, means or is equivalent or has to do with function. You know what functional programming is? Tomorrow, in the other class, we will work on that. What does it mean, functional programming? Take a wild guess. Functional programming. Functional programming. It's not very complicated. Functional programming.
Using functions?
Yeah.
By programming?
It is not very complicated, right? Functional programming, you use function, right? I don't know if, I think it was, no, I don't know if it's this class or the other class, I think this class. We talk about programming paradigm, right? Different programming paradigm. And then we talk about OOP, right? And then another functional another paradigm, very important historically, is functional programming. What is the difference? Well, when you are a developer and you are programming in a language that follows the object-oriented paradigm, in your mind, to solve the problem, all you have to do is to come out with classes, right? Because in your, not in reality, but in your abstract, in your abstraction of the machine, you think about objects which are doing tasks, and those objects belong to classes or are instances of classes. And the fact that an object is an instance of a class basically determines what task the object can do, and those are essentially the methods. And the object has a state with information about which will be used to carry out the task, plus the information provided by the argument passed to the method when the method is called on that object, right? Yes? So that's what you have in mind. Now, in functional programming, you don't have that. You just change your mind. And now, what you have in mind is function. All you have are functions. Okay? So basically, the whole program is one function calling another function, calling another function, calling another function. Okay? There is, and that's a big issue, there is no state. There is no state. Okay? And that's easy to and that's easy to understand. So I think I asked this question before, but a function f, right, takes an argument x, y, and return a result, which is z, right? Now, This result depends on what? Depends on X and Y and nothing else. And nothing else. Right? That's the idea of a function. Of course, depends on F, but I mean, given the F depends on the argument. Right? Okay. If I have an object O, right? And then I call a method, now it's a method, F, that pass X and Y. First, does it return a set in object oriented? Does it return a set? When you call a method on an object, does it return does it return a value? Huh? Okay, let me ask another question. Could it be the case that it does not return any value? Yes? And I think you can say that's right? Because the result may be here. The result is a change of the state in the object. Right? So that's the first question. Calling a method in an object may not return a value. That's the reason we have the word. But that's not the case here. When you are doing functional programming, that is not the case. When you are doing pure functional programming, that is not the case, and it's a huge issue. Now, so first, it may not return us a value. It just changed the state of the object or changed the state of something in the system. Second, the value or whatever it does depends on what? When we do this, depends on, you told me before, but depends on this one. And now depends on what? X and Y? X and Y plus the internal state, which is not the case. Okay? So when you go, so suppose that you have this, you are programming in Java, and now you want to move to Haskell, okay, which is a functional programming language. So what do you have to do? What is what we normally do? So basically, all the state here becomes arguments here. Your function has more arguments. You can either, even in object-oriented programming, you can either keep the information as a state in the object or pass the information as arguments to the method. Up to you. Okay? Good. Now, these guys, right? So AWS provides Lambda. Lambda, what is Lambda? Lambda are functions. Function. Okay? Which are running, are executed somewhere, which we don't know. In some hardware, somewhere. We don't know, we don't care. Because what AWS does is, when you declare your Lambda, it gives you a URL, an address, that you can use to call the function in your code. Right? So basically, I guess in the past, when you develop a web application, this is just an example, you develop a web application, you have a server somewhere, right? Yes? And in that server, you install, we will do it today, you install a web server. What is a web server? What is the key thing of the web server? But that's similar to, okay, connectivity, but okay, let's say connectivity. Where are we? Here. But that doesn't tell me anything specific about why it's a web server.
I guess that it exposes some kind of like API to the outside world, you can call it.
Yes, but that is any server, in a sense. So what is the difference between a web server and a mail server? A mail server has connectivity, a mail server exposes something to the world. What is the difference?
Maybe it can get the user interface.
How far?
No?
What is the difference between mail server and a web server? No? The key word is protocol. Protocol. So what is the difference between a web server and a mail server? Well, the web server understands. So it has software that understands communication on the HTTP protocol. While the mail server, it has the software to understand the whatever mail protocol you are using, SMTP or whatever it is. That's it. Okay, so understand, so what does it mean? Did you study the HTTP protocol somewhere? HTTP protocol? HTTP. You understand? So basically, in order to carry on a communication based on the HTTP protocol, then both the client and the server need to be communicated, need to be connected, right? But need to understand the syntax of the semantics of the request and of the response. And that's the request is gonna have it's gonna contain the URL of the URI of the resource that want to request, and the server need to somehow map those URI with the specific file system that the server has. Okay? Good. So that's a web server, right? So what is the magic here of the Lambda? So sorry, going back. You put the web server, and then to deploy your basically you put here, right? You deploy a bunch of APIs. Right? And then it is a web server, and then for example you say www.test.com.foo.index.html, right? Foo is your application, your web application, and index.html is one of the files that you have there. And when you deploy your whole web application into your server, the server do the magic to put index.html in a place that when a request comes to foo index.html, it knows where it is. It knows where it is. Okay? That's the role of the website. The Lambda is like, you don't have this, and therefore you still have this. You have your code, but now you deploy your code in a web server that you don't know where it is. but it's a web server. And what AWS does is to give you back the API, the URL. The same thing. It gives you the URL. Of course, it's not the URL that you expect. It's the URL that the web server that is behind the scene, AWS has. Because someone needs to do the magic of linking the URL with the actual file. File could be HTML, file could be a code, file could be whatever. Okay? So that's what Lambda is going to do. So it's the same, except that AWS put the web server for you. You don't need to put the web server. You still need to do a code, of course. And you need to deploy, of course. And you need to access. But now, before you access with the API like this, URL like this. Now, you access with the URL that AWS gives you. A bunch of characters. Okay? That's Lambda. So what is the advantage of Lambda? Well, you don't need to have a server because you don't have a web server. You don't need this because you don't need this. So that means you don't pay for this and you don't care about this. You don't need to install, as we will do later. You don't need to upgrade. You don't need to take care. Because it's on you. That's basically the advantage of Lambda. And that's the reason Lambda, the same thing I say server, Lambda is server. It's an instance of the serverless, no server approach for deploying your application. Now, as we will see, of course, because as I said, this is running on a server and it's completely different a server that offers Java based APIs, that is Python or Node.js. When we will declare in 3 weeks the Lambda, we will have to say this Lambda is on this, written on this programming language, and this is the on this programming language. Okay, and with this version. And that's it. As happens in many of the services that we are using, things are not so clean. Ideally, right, you would like to take this is a file, right? Your API is implemented in a file. Whatever, file. No. You would like to take this file and put it here. It doesn't work. You need to do some wrapping to prepare your code to deploy as a Lambda. And that is not nice. But it's the way it is. Now, when we have a server, in the pricing, so meaning it's infrastructure as service, meaning we install, we maintain, we take care, and we pay. And we pay, currently, we pay based on the, of course, based on the size, based on the power meaning the compute power, how, and based on the hours, in the case of EC2. Because an EC2, as we will see, it has essentially 3 states: start, stop, and terminate. Start meaning running, stop meaning not running. Not running, but there. It's like you take your server and shut it down, but it's there. You can shut it. You can start it again, and everything is back to normal. Terminate means you take your server and throw it away to the trash can. Meaning there is no way you will recover anything that it was there. So, right now, because the pricing schema for EC2 is you pay per hours, if you don't actually need a server, right, because you are testing things, then the proper way of doing things is you start your machine, you stop your machine, because then you don't pay. But if you need a server, because you have clients, and your application is offering some service to a client, then basically you have to keep it on all the time. Yes? One difference which is not important, I think, for today, for us, but it is important when you have clients or you have other code that depends on your server. When you stop your EC2, then the address that AWS has assigned, the IP address that AWS has assigned to your EC2 is released, and next time you start is a different one. So let's say that you have a code that is accessing, you have a script that is accessing on that IP. It will not work because the IP has changed. Okay, so that's. Of course, there is a way of assigning fixed public IP to your EC2, right? But of course, you pay. So we are not doing it. But if you want to continue with your server later on, it's the best thing to do. You ask AWS to assign a fixed public IP, so even if you stop your machine, it does not change. Make sense? Yes. Then there are other services in the compute category, which I don't think, so some of them, I don't think they are interesting for us. Others, it depends, we have kind of not to cover. So one is everything having to do with container, which this is Kubernetes, Docker, and all these things, which if we have time, we will do it. And then there is something called beans hub, and something called light cell. So these are not infrastructure as a service, but they are platform as a service. So basically, it's like a Moodle, where you can add things, but the things that you add are actually your web application. So, meaning, there is a server, and then AWS, in the case of Beanstalk, AWS, you say, I want a web server for Java application. So AWS automatically install the web server for Java web application. And if you are front end, if you are a management console to deploy, to upload your application. So you don't need to care about the server and you don't need to care about the web server, but your EC2 only works for that, and you pay. And as we said last time, the more you ask AWS to do for you, the more you pay to AWS. I really don't like or didn't like this, and in fact, as far as I know, it's kind of dying away because both of the solutions are better. Okay? So, any question? Yes.
What are the advantages of having a fixed public IP compared to a different IP that can now access
Right. suppose we have a server. Suppose that you have an EC2, right? That EC2 has a web server, right? And in the web server you have an application let's say, test, and you have to embed HTML, right? But before here, right? So and now I'm here, and I have my browser, and I want to access embed HTML, right? So I have to put here the IP, right? Plus test plus index HTML, right? Now, and suppose that I'm super lazy, and I just copy this in my Google Sheet, and I just keep adding, or I put it in my preference. It's called the bookmark, right? Now I stop this because I don't want to pay, and I start it again. That doesn't work anymore.
Just the URL and then the domain name system, which was
You say domain, right? You say this, right? Right? Okay. We know you have studied DNS, right? So what you are saying makes sense. If now I have a domain, then I couldn't care. If I have a domain. Now domains are not free, right? You have to pay. There is a service, of course, there is a service in AWS to there's a service in AWS where you actually buy and they pay for you the domain, but you have to pay $12, depending on the domain, and $1 per month. So we are not allowed to do that. But yes, if you move to the domain, if you say, no, I have my domain, then what I said is not so relevant. Okay? Still, the domain, you keep the domain. So the domain don't do magic. The domain, you have to say, this go with this IP. Because you keep the domain. You are the one who set up the rules, not AWS. But essentially you have to pay. And it's a nice service. We may do that, okay, at the end of the course, when we study something called API gateway. Okay? We may, which is another way of solving certain problems. And there, if we have time, then we will create the domain and things are going to be nice. Thank you. Yeah? Any other question? No? Okay, so let's create a, so please enter into your into AWS. Sign with the, I think now you have 2 users. You have 2 users, right? You have the root user and you have something called Cloud 25. So because we are going to do administrative thing, we are going to, please enter with the root. So please check that you enter, right? Check that still you have 0. Everybody has 0. Everybody who should have 0 has 0. We are in, right? So I'm gonna keep going. So if someone has a problem, please let me know. Otherwise, you are gonna lose from now on. Everybody has a problem. Everybody enter. You are not gonna have the same thing. This is my account, right? So these are my. Let's see if I can. Okay.